Basically, I'm here to give you an introduction to objective gait analysis. So myself, I am one of the inventor of one of the systems you have here at the university. And we will also use the stance analyzer. So I don't know if you're familiar with it or not. But, so the first part will be more theoric. I will explain to you what is it, what we do, and after we will do we'll split the class in two groups, and one will be more practical and play a little bit with the two tools that we have here, while the other one will be more literature, check the research that have been written, and after we'll split. So if you have any question during my talk after, etc., feel free to ask me. So it's not a problem to interrupt me. So first of all, what is so gait analysis? Basically, it is just a tool to give you context about a dog or equine. So as you saw in the previous slide, we do both equine and canine for myself. But today I will be focusing more on canine. So it is a way to, with a simple protocol, to give you two graphs. So this is the Tendiboots application that you see on the left. And so basically we give you two graphs that you can use very easily in a daily practice. So it will be a symmetry result and a history, so you can see how a dog is evolving. And we try to help you. When I say you, it is the user. It is can be a vet, a physio, a vet nurse, anyone around the health of the dog or the animal. And we help you to decide better with more objective tool if you should go deeper in the investigation, space the visit, etc., etc. And I will explain to you just a little bit after. So just a quick introduction of who I am and why I am doing this talk and why this subject matter to me. So I am Stéphane Jupin. I am one of the co-founder of Tendiboots that we will see after. I have a computer science engineering degree in real-time embedded system. Before that, I was also doing the same kind of stuff. So basically turning sensor data into actual numbers that you can use, but for a completely different subject, which is a motorsport. So it is the same whether it's a vehicle, it is a robot, an animal, or an athlete. You can turn sensors data into actual numbers that say something and help you decide objectively what you should do or what you should not do, etc. So we built the Tendiboots canine system since now 3 years, but we have been doing that since almost 10 years, first for equine and after for canine. And what I will show you later comes from thousands of recordings that we have made, not us, but the user, because we have more than 300 professionals using the system every day in the clinical environment. So we start to know pretty well what is a healthy dog, what is a dog that is starting to be not good or not usual. So I will explain to you this later. So first of all, the clinical problem that everyone will face on a daily basis, it is lameness. So in most cases, seeing the lameness is not very the issue. Most of the time it is clear. Sometimes it's a little bit subtle, but the hard part is agree on the lameness. So which limb is affected, and most importantly, to document the lameness and to know, for example, 2 weeks or 1 month after, is it better? Is it worse? So this is why objective measurement tools come into play. This is a tool to help you know if it's better or not. And we understand that most owners want, I said proof, but it's not proof. It's they want to see. They want to see if their dog is better. They want to see if what they do every day in their house is useful, basically. And so yeah, that's it. So yes, the goal is not to replace the skill of the vet or your eyes or anything. It's just another tool in your toolbox to use and make it easy to compare before and after. So we will see where Tendiboots. So you know that there is Tendiboots, there is a stance analyzer, but there is not only this tool. There is three main families of objective measurement tool that we have. So the first one would be visual assessment, and I would like to ask you if you have any idea of what would be a visual assessment that you can use in everyday practice. So if you have any idea, what will it be? Nobody? Anyone? It is just your eyes and your experience. So it is the basic level of objective assessment tool, and there is also slow motion video. So this is the one that you see the most often on the daily life. This is what vet use. But we have also static tools, which is a weight distribution that we can see here, for example, and pressure mat. And the difference is that weight distribution will only tell you how much force is there on each limb. Like when you go on your weight scale at home, it will tell you how much you weight. And pressure mat will give you more indication of how the paw is pressuring the ground. So is it more on the front of the paw, or is it more on the middle, in the back, etc. So it's a little bit different. And you can also use these two tools dynamically, but here I say static. And the last one is dynamic tools. So we have the force plate, instrumented treadmill, and motion captures, and wearable IMU. So the last category is what you will usually see as an objective measurement tool in the daily practice, because this is what it is the most easy to use on the daily life, except from the visual assessment that everyone has now. With everyone has eyes, and slow motion video with the smartphone now it's quite easy. But we will focus more on the last part. So yes, as I said, objective gait analysis is basically just turning movement into numbers that we can compare over time. So instead of saying the dog looks better, we can say okay, the front left stance time is getting better compared to last time, because now the symmetry is 48%, and before it was 40%. So it is just that. And for that, you need obviously a repeatable protocol. So it is the most important thing, because if you want to compare before after, you need to make sure that your protocol is the same 1 month, 2 months, 3 months every time. So if the protocol changes, the number will change. So it's like any other tool. You have some rules that you should follow. And for the measurement, there is three main families of things that you will always see, whether it's with a static, with a dynamic, or anything. It is always the same. So you have, first of all, the spatial temporal things. So it is basically the stride length, the stance time, the stride duration, the cadence, all of that. So it is how fast and how far the dog can go, or the limb, etc. you have the loading or the force. So basically, it is how much limb, how much weight is on the limb when it touches the ground. So it can be the peak vertical ground reaction force, so the peak vertical force, the Newton per kilogram, the symmetry and this, etc. And the last one is the motion pattern, the movement pattern. It is how the limb is moving on a 3 dimension. So the trajectory of the limb, the range of motion, all of that. So you will always see this kind of 3 categories, whether you use any kind of objective tool or gait analysis. So it is always difficult to have one rule when we say there is a lameness. So a lameness should be like A, B, C. There is no absolute rule, but we can give you an idea and help you. So basically, a lame limb will often show so less peak vertical force and a shorter stance duration. Because usually, even for you, when you have pain on one leg or one foot, you will try to put less weight and stay less longer or shorter on this limb. So it is basically the same, and the number should reflect this reality. But this is not an absolute truth, and some specific condition, or depending on the dog, it can react differently. So this is living animals, and they have multiple things that can affect this pattern. And when there is lameness, there can also be, first of all, there can be multiple lameness, the primary one and the secondary one. So this can make the number more difficult to interpret, etc. But there is also a phenomenon that is compensation. So when one limb is limbed, the other one will get more load and a greater stance duration, for example. And there is one other category that is a little bit apart from this, which is a neurological case. And for example, this case is different because it will not be something that that you can predict, because neurological case will affect the locomotion in a different way, which is the stride time will be messed up a little bit. So it is very irregular, yes, as I say, irregular timing, inconsistent, rather than just less load and shorter stance time. So some of our users, for example, use the Tendiboots to help them to define if it's an orthopedic issue or a neurological issue based on this criteria, for example. So if they see that the numbers are messed up a little bit, maybe they try to think differently. So this is one of the cases that the tool is useful also. So if we go back to Tendiboots, so basically it is holder that you place on the limb like that, above the carpal joint and tarsal joint. And inside the holders, there is IMU, as we say. So IMU is the inertial motion unit. Just to give you context, it will tell you in 3 dimensions how the limb is moving. And each time the paw will hit the ground, we will detect this motion. And each time it is in the air also, we will detect. And we will give you a symmetry. For each limb, we will tell you, for example, the stride length of each limb, the stride time, all the parameters that we saw earlier. And we compute all of that to give you a symmetry between left and right. So we try to make it very easy and to use in the daily practice, because there is a lot of tool, lot of heavy tool that is very expensive, very complicated to use on the daily practice, and this is not this kind of tool. This tool is to be as fast as possible to use, so it incorporates well in the daily practice. So just quickly, I will not get too deep into the technology, but it's important to know how it works, because knowing what what it do and how it works make sometimes a little bit better to understand the outcome. So first of all, for example, this is, for example, the trajectory of a limb in 3 dimensions. So we know for example, the paw starts here and the limb do this kind of trajectory. And based on that, we can see each stride easily because we detect when the limb is in motion, and we are able to detect exactly the peak speed of this motion. From that, we, we say the limb is on the ground, the limb is on the air, so we know exactly when it hit the ground and when it is in full load. And based on that, we can compute all of that. So what I shown you before, all of that you don't care, you will never see this. And you, in the daily life, you will see this kind of information, which is more easy to digest and to understand and to explain to the owner, to the vet, to whoever it could be. And if you, for example, if you press on each measurement, you will get an indication of what it is, etc., etc. So if you see this for the first time, it can be a lot of number, but after a few trials, it starts to be easy. So the thing to remember is that we give a very straightforward protocol to use, because as I said, a tool is good, but only if you follow some rules and some protocols that you can apply easily. So first of all, and you will experience this later when you do some tests. What we recommend is to feed the holder on the dog. So first, you put this on the dog, empty, without anything, and you feed all four, and you let the dog move a little bit because the dog will juggle a little bit, it will dance, so it's normal, it's part of the process. So this is what we call the short warm-up. And after, when you are ready, you put the sensor inside all the holder, and you let the dog walk for 10 seconds. So it is automatic. You start and it will count down until 0, and you have nothing else to do. You just have to check that the dog is at a regular speed, it is on a straight line, and the behavior is good. And you repeat that 4 times, and after you merge everything, and the software take care of everything, and you will get the kind of numbers that you saw just previously. So it should take 5 minutes total. So when you are used to it on the daily life, it takes less than 5 minutes to do all of that. It is very quick. So as you saw previously, you will get basically 2 graphs. This first graph is the symmetry. So we take each parameter that we saw, the stride length, for example, the peak ground traction force, and we compare left and right to give you an indication if it's on the green zone, which is what we usually see for a healthy dog. It's not an absolute truth, but we could say that 2/3 of healthy dog will fall into this category. Or if it's outside, and in this case, this is why you should maybe start to say, me, I saw something unusual, the system sees something unusual, so there is a correlation between the two observations, and maybe we can investigate further based on this parameter. So if it's a peak ground reaction force, it is a load, so maybe there is something. If it is a stride length, maybe this is something else, and this is how the teamwork should come into play. We will not tell you what is it, but we'll give you just another indication to help you investigate further. And the second graph that we have is the history graph, because as I told earlier, it is good to know 1 month from now the dog was like that, and now it is better, is it worse? So basically, if the dog is on the 0 line, that means it is perfectly symmetric between left and right. So it is not usually the case, because even us as humans, we are not perfectly 50-50, but it is a trend to try to follow. So I have just two cases to show you, to just demonstrate how the system can react in different conditions. So for example, this was a dog that saw a chiropractor, I think. And as you can see, so it is based on 100 strides. So you can do 4 measurements, which is the minimum we say to have a good uh, correlation between the number of strides and the quality of the data. But you can do up to 10 measurements, so you can go for more than 100 strides. So it is a very good amount of data to have an idea of how the dog is moving. So, for example, here we saw that this dog was on the red part on multiple parameters, either on the forelimbs or the hind limbs. And so this dog had some manipulation with the chiropractor. And what we see when we check just after the manipulation, we see that there is an improvement clearly, which is what also the vet saw, or the chiropractor saw. So it is a nice tool to subjective to objective measurement. So he saw it was better, he did the manipulation, and the system also sees that it is better. So now we see it, for example, 1 month later, and we monitor this on a regular basis, and this is how the tool can be used. But there is also another case, which is, for example, this one was nothing was detected. The system also detect nothing, even if there is sometimes some at the limit. But when it did also the manipulation, and the dog was still on the green zone, even a little bit better. But it is just to say that sometimes it is good that to monitor even if the dog is good. The system should also say that it is good, and it is just another situation when you can use this tool. So as I said, there is something that you should know you can do, and something that you should avoid. This apply to this kind of tool, but this is the same for the stance analyzer or the visual assessment or anything like that. So use trot on straight line as much as possible. You can, for example, for our tool, you can record at walk, but we recommend doing trot as much as you can, because this is where the asymmetry will be more visible, and it will be more easily highlighted by the system. Keep the surface similar between each measurement. So ideally, when you are somewhere, fix a spot and always use this spot to make your recording. And if the dog is not normal or if there is anything wrong, just delete the measurement and do it again, because it only takes 10 seconds. So it's not a good a lot of time. It's better to do it again. And just check that the dog is walking the more freely as possible, in a more natural way as possible. And for example, if the dog is walking, trotting at the same time, or you're not sure, this is something to avoid. As I said, let the dog move freely. And if you see anything that is weird to you, do not hesitate to do another measurement. So whether it's static, dynamic, repeat multiple times to have, as I say, a good number of data, whether it's stride or time or anything. It's better to have multiple rather than just a few one and don't understand the result. Very quickly on this slide, it is the green zone as you saw previously. So basically, we have collected thousands and thousands of recording of dogs that we know are healthy, and basically this is how the, they show when we compare left and right, and so we have taken the majority of them, and we are able to see that the green band is a reference from the dog that have been diagnosed with nothing. So as I said earlier, we are not always perfectly 50-50, and this is a good representation, as even if dogs are healthy, they can be a little bit more on the left, more on the right. So we take the majority of the dog, and this is how we have explained the green zone and the red zone. So the three questions to finish that we help you answer. It's not a magic number that say this dog is lame, this dog is healthy. It is just something that you use, give you an indication, and you correlate this with the visual assessment, and you are able to say if you saw nothing, the system saw nothing, it is good, and this is just a monitoring tool or reassurance tool for you, for the owner or anyone, and you can go on. Or if there is you saw nothing but the system saw something, maybe you will think about it. Maybe the team will try another trial and do it again. So it's just to make you think about it and maybe investigate further. If compared to the previous one, also, is it better? Is it worse? Can you the last visit, for example, was 1 week. Maybe now you can do 1 month. It is just to make your protocol easier to plan, for example. And you, for example, your role is to make sure that you have followed the same protocol every time. So we can know that this number today is the same as has been collected the same way as 1 month earlier. And finally, when does a recheck make sense? So if it's still outside this green zone, maybe we can make the next exam not so far from now, or if it's just stable, but you can space everything. So yeah, this is wrap up that what I said. So choose one corridor, one surface. You have the two graphs that you saw just earlier that you can use on a daily practice. Should you investigate further or not today? Should you change something in the plant? And when do you schedule the next visit? To finish, so Tendiboots or any objective measurement tool does not replace your hands or your eyes or the professional that is taking care of animals every day. It is just a decision support tool that is designed to strengthen the clinical assessment that you do, support the treatment plan, and communicate progress more clearly with the owner or with the team. Because when you document much better, everyone is more focused and more aware of the condition of the animal. So for the theory part, it's okay. So I don't know if you have any question about what we say or what I said.